Alright guys, we're going to do some special trig limits. We have two that we are going to look at, and we're going to show several examples of how they can be modified. And that's the limit as x approaches 0 of sine x over x, and even if it's flipped over, if it's x over sine x, they have the same answer. And then the limit as x approaches 0 of 1 minus cosine x over x, or cosine x minus 1 over x. And I want to take a look at the graphing calculator first before we go through and do some examples of these. So let's take a look at sine x over x and x over sine x and look at the limit as x is approaching 0. So I've got my graphing calculator here, and I'm just showing sine x over x, or x over sine x, and we want to make sure we're in mode radians. You've got to be in radians for this. So let's graph it, and we can see that as we're approaching 0, in both of these cases, we are approaching the y value of 1. So the limit from the left and from the right in both of these cases is 1. And we go to the table, however, and we can see that at 0, we've got an error. That's because if we plug in 0 for x, we're going to get 0 over 0, which we know is that word indeterminate, and which means there's things to do. And you've learned algebra and other stuff, but here these are just special trig limits that there's not really algebra to show. So you just have to know that both of these are equal to 1. Now let's go take a look at the cosine examples, however. So let me turn off these two graphs. And so we're going to have 1 minus cosine x over x, or if it's cosine x minus 1 over x. We're going to take a look at those two graphs and see what they're approaching. In both instances, as we are approaching 0 from the left and from the right, you can see that we are approaching 0 from both sides. And if we go to the table, of course we have an error there. But we can see from the graph that the limit does exist, because from the left and from the right it's approaching 0. So we're going to say that both of these are going to equal 0 in either form. So those are the two special trig limits that we're going to play with, and let's go do some examples now. Alright, so I've got the limit as x approaches 0 of sine x times cosine x over x. And we've got to work this out. So what I'm going to do is I'm going to split this up into two limits. Because of our properties of limits, we have the right to do this. So I can have the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of cosine x. Now this is our special trig limit, sine x over x. We know that that is 1. And then the limit as x approaches 0 of cosine, we can just plug in 0 for x, and of course we know the cosine of 0 is 1. So the answer to that limit is 1, and we get 1 as our answer. And so that answer is A. That's pretty straightforward. Let's take a look at another example. What about sine of 4x over 2x? Now, I really wish the 4 and the 2 weren't there. It would be a direct application of our special trig limit, sine x over x. So this is the trick that we can do. You need to understand that the sine of banana over banana, I know that's silly, but as long as we are allowing banana to approach 0, that's going to equal 1. That's just sort of a silly example there. So what I'm going to do is I'm going to multiply by this clever form of 1, which is going to be 2 over 2. And I'm going to show you why I did that. I'm going to allow this 2 on the bottom to be multiplied times that 2x, but this 2 on the top, I'm going to bring it out in front of the limit. We learned these properties, you know that we can do that. So I turn this into 2 times the limit as x approaches 0 of sine of 4x over 4x. So what I did is I multiplied this 2 times that 2x to get the 4x, but I left the 2, I didn't multiply the 2 times the sine, I just put it out here in front. And so what I've created here is that silly example of banana over banana, but this is really 4x over 4x. And so what is the limit as x approaches 0 of sine of 4x over 4x? Well, it's 1, because those are the same thing. And so all of this answer to this limit is 1, and I've got that 2 out there, so this answer works out to be 2. Let's do another example. What about sine of 2h over h squared? Well, here, I really would like this to be a 2h down here so I can just say that it's a 1. So let's see what we can do here. The limit as h approaches 0 of sine of 2h over h, and then I'm going to bring the other h out here. So there's my h squared. And the trick here is I'm going to multiply by 2 over 2. I'll leave the 2 in the denominator, but I'll take the 2 in the numerator out in front. So I've multiplied by 1, and I've separated this because this wasn't an h squared here, so I've pulled that h out. So the answer to this is going to be 2 times the limit as h approaches 0 of sine of 2h over 2h, and then times the limit as h approaches 0 of 1 over h. So this, of course, gives us 2 times these match, so that limit is 1. Now let's do the limit as h approaches 0 of 1 over h. If we plug in 0, we get 1 divided by 0. That is not indeterminate. I guarantee you that we are dealing with a vertical asymptote. That limit is undefined. That limit does not exist. It's actually infinity. So I've got 2 times 1 times undefined, and if any part of a multiplication statement is undefined, then the whole thing is undefined. And so this answer is E. Let's do another example here. I've got signs in both the numerator and denominator. So what we're going to do is we're going to separate this as the sine of 5x over 1 times the limit as x approaches 0 of 1 over the sine of 8x. So I'm going to show you my clever form of 1. This first limit I'm going to multiply times. What would I like to have down here? I'd really like to have a 5x down here, right? Because if I had a 5x down here, then that would cancel with that. But I can't just do that. I've also got to do a 5x up here, so that I've got my clever form of 1. Okay, and then over here, what do you think I'm going to do? Well, I'm going to multiply by 8x over 8x. See that? So let's see what we can do. This 5x I want to come in here in the bottom so that I have that matching up. A little matchy-matchy game. So I'll have the sine of 5x over 5x. And then this numerator for this 8x I'm going to take up there. So I'll have the limit as x approaches 0 of 8x over the sine of 8x. What do I have left here? Well, I've got this 5x left up here that I haven't dealt with, and this 8x left down here that I haven't dealt with. So I'm going to let those come all the way out in front because I don't want them in here anywhere because they mess up my trig limit. Alright, so let's see what we can do. Those x's can cancel and I can get 5/8 for that. Now the limit as x approaches 0 here, since those match, that's 1. And also even in this form, since those match, that's also 1. So we get an answer of 5/8. Oh, by the way, Selena, you left your cell phone here in my room. So anyway, somebody just messaged you. I'm not looking at it though, trust me. So anyway, this answer is 5/8. All right, now what about this messy thing, sine squared? Well, I'm going to get you started on this. This will be the limit as x approaches 0 of sine of 2x over 1 times sine of 2x over 1. That's sine squared. And then times 1 over the sine of 5x times 1 over the sine of 5x. So that's your hint for how you could start that. Of course, you would need to multiply by a 2x over 2x here, a 2x over 2x here, 5x over 5x here, and 5x over 5x here. So anyway, from there, it's just like the previous example, so I don't want to waste your time with that. Let's take a look at number 9 here. This is just like my silly little banana example. Since these things match, what do you think this answer is? It's 1. Ah, that's so easy. Okay, so let's do an example where I've got to do some factoring. How about 2 sine x over, that factors out of an x, and that's a 2x plus 1. And then I have a cosine x over 1, and I'm going to take the limit as x approaches 0. So let's see what we want down here, what we don't want down here. Well, you know, the 2x plus 1, I don't really want that here. I'd just like this to be a sine x over x. So let me scoot this down a little bit. So I'm going to bring the 2 out, and I'll have the limit as x approaches 0 of sine x over x, and then I'll have the cosine x over 1, and then I'll have the 1 over 2x plus 1. We got to take the limit as x approaches 0 of all of this, so that a limit gets applied to everything in here. So the limit as x approaches 0 of sine x over x, we know that's 1. Now cosine x, you plug in 0 for that, cosine of 0 is 1. And if you plug in a 0 for this x, you also get 1 there. So what do you think this answer is? Well, this answer works out to be 2.